Hello dear students, this is Sheikh Zameer. I welcome you all on my YouTube channel. Today in this video, we will see example based on orthogonal trajectories. So let's proceed. So first we will see what is orthogonal trajectories. Its definition is when two families of curves are said to be orthogonal if every member of family curves each member of other family at right angles. It means when two curves curves each other at right angle, then we can say that these two curves are orthogonal to each other. So the examples based on orthogonal trajectories, there is one equation is given in each and every example, and for that particular equation we have to find out the orthogonal trajectories. It means the equation which cuts the given equation at right angle. So we will see the method of finding orthogonal trajectories. We will see the Cartesian form here, the equation which includes two variables x and y along with arbitrary constant c, or we can say arbitrary constant a. This is called as the equation in Cartesian form. For that kind of equation, to find out its orthogonal trajectories, we will have to follow these following steps. So first what we have to do, we have to write down the given equation and make it as equation 1. This is the first step. Then we have to differentiate equation 1 with respect to x, and we have to find out dy by dx. So whatever may be the value of dy by dx, that equation we will make it as equation 2. Then if the equation 2 includes any arbitrary constant like c or a, that arbitrary constant should be eliminated by using equation 1. It means we have to find the value of that arbitrary constant by using equation 1, and that value of constant we have to put up in equation 2, and then we will replace dy by dx by minus dx by dy. After that we will separate the variable to take the integration of both sides to get the final orthogonal trajectories of the given curve. So this is the method we have to follow to find out orthogonal trajectories of a Cartesian equation which includes two variables x and y along with arbitrary constant c or a. So let us proceed for one example based on this. Now this is the example based on Cartesian equation. We have to find out here the orthogonal trajectories of this family of curves. So there is one curve is given, that is an equation. For that particular equation we have to find out its orthogonal trajectories. So first of all what we have to do, we have to write down the given equation. Given equation is, that is ay square equal to x cube, and we will make it as equation 1. Then we will differentiate this equation with respect to x to get dy by dx. So I am differentiating both sides with respect to x. So we will put up the derivative symbol on both sides. As our differentiation is with respect to x, on the left hand side we can see that this a is constant, so we will keep it aside, and then in the next step we will take the derivative of y square. On the right hand side, derivative of x cube is 3x square. Now derivative of y square is it is 2y, and into derivative of y with respect to x, we have to write down each and every time, that is dy by dx. It is equal to 3x square. Now on the left hand side, what we will get? It is 2ay into dy by dx is equal to 3x square. Now to get the value of dy by dx, we will transfer this term 2ay in the denominator. So that term will go in the denominator of the right hand side term, that is 3x square upon 2ay. So this is our equation number 2. If there is any kind of cancellation is there in equation 2, that we have to do it, or else we have to keep the terms as it is if there is no other cancellation. Now we can see here in equation 2 there is one arbitrary constant, that is a. If there is any arbitrary constant in equation 2, that arbitrary constant we have to eliminate by using equation 1. So in equation 2 we can see here that arbitrary constant is a, and that a should be eliminated by using equation 1. So to eliminate a by 1, by equation 1, we have ay square is equal to x cube. So by using this equation, we have to find out the value of this arbitrary constant. So we will transfer this y square in the denominator. So it becomes x cube upon y square, and then we will put up this value of a in equation 2. So putting a is equal to x cube upon y square in equation 2, we get, so equation 2 becomes dy by dx is equal to 3x square upon 2a is x cube upon y square into y as it is. So we have just put up the value of a in equation 2 here. So it will be like this. Now what we will do, we will simplify this term completely for the next step. So this denominator will become like this. I will just multiply this term first. This 2 into x cube into y is 2x cube y upon y square. Now in the next step, this y square will go in the numerator. So as per the mathematical calculation, this y square will go in the numerator in the next step. So it becomes like this: 3x square into y square upon 2x cube y. So as we know that if the term is like this, a whole divided by b divided by c, then this c will transfer in the numerator. So it will become like this. Now we will see here if there is any kind of cancellation is there, means here x square will get cancelled from x cube, one y will get cancelled from y square, and the remaining terms we will write down in the next step. We can see here in the numerator the remaining terms are 3 into y. In the denominator what we will get, it is 2x, that x square is cancelled from x cube, and that one y is cancelled from y square. So in the next step, the remaining terms are dy by dx is equal to, numerator is 3y and denominator is 2x. So it becomes 3y upon 2x. Now in the next step, to find the orthogonal trajectory, we will replace this dy by dx by minus dx by dy. So we have to replace dx by dy by minus dx by dy. So here we will put up dx by dy minus dx by dy is equal to 3y upon 2x. So for this dy by dx we will write down minus dx by dy, and then we will separate variables here, separating variables. So how we can do the separating variables? First we will transfer this dy on this side as it is in the denominator, so it can be directly transferred on the right hand side in the numerator like this. Then we will keep all the terms which includes x along with dx and all the terms which includes y along with dy. So this 2x along with this constant, we will keep this 2x along with dx. So it will becomes like this, 2x dx. We can keep it along with that constant also, and on the right hand side it is 3y dy. We will readjust the terms. We will transfer this term completely on the right hand side. So changing the side of this term, we are transferring this term on the right hand side. So this minus 2x dx will become plus 2x dx. So after transferring this term on the right hand side, as its sign is negative, when we will transfer this term on the right hand side, it becomes positive, and already this 3y dy is there along with the plus sign. So we will write down this as plus 3y dy. And then in the next step, we will write down this term on the left hand side like this, 2x dx plus 3y dy, and on the right hand side we will write down as 0. So we will just, if a equal to b, that can be written as b equal to a. So I have just write down this term on the left hand side and this term on the right hand side. So now in the next step we will put up integration sign on both sides. So to get the orthogonal trajectory, after separating variables and keeping all the terms on one side, we will integrate both sides. So see here, integrating both sides to get the final answer. We will integrate both sides after separating variables. So now I will put up integration sign with each and every term. See here, on the left hand side, we are just putting integration symbol. On the right hand side, already 0 is there. The integration of 0 is 0 itself. So there is no change on the right hand side. But on the left hand side, we will put up integration sign along with each and every term. Now here, integration is with respect to dx. So we have to take the integration of only the term which include x variable. Here, integration is with respect to dy. So we will have to take the integration of y variable only. So this 2 is constant, keep it outside. This 3 is constant, keep it outside. So this 2x dx plus this 3 is constant, 3y dy is equal to 0. Now we have to find out the integration of x dx and integration of y dy by using this standard formula of integration, that is integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. We can see here the power of x is nothing but 1, the power of y is nothing but 1. We will apply this formula for both the terms to get the answer. So it is x raised to, here the n is 1, and for this term also n is 1. Only variable difference is there. For second term we will use the variable y, and for first term it is at x itself. So this x raised to 1 plus 1 upon 1 plus 1. We are using this formula, x raised to n plus 1 upon n plus 1 for the first term, and for the second term also just the variable is y there. So we will put here y variable, that is y raised to 1 plus 1 upon 1 plus 1 is equal to, now here we have taken the integration. So in that step we have to add constant of integration c on the right hand side. Keep remember the step in which we have taken all the integration. In that step we have to add constant of integration on the right hand side. So this c is nothing but constant of integration. Now we will simplify the left hand side term. This 1 plus 1 is 2. So the x square by 2. Here for the second term it is y square by 2. On the right hand side this 0 plus c is c. Here this 2 and this 2 will get cancelled, and here there is no simplification, no cancellation. We will put the second term as it is. So this x square plus, we will multiply this term, so it becomes 3y square upon 2 is equal to c. So this is the required orthogonal trajectories of the given curve. It means if we plot the graph of both the curve, these both curves curves each other at a right angle. So this is how we can find out the orthogonal trajectories of the Cartesian equation. And this method should be applied for each and every example based on Cartesian equation. So we will just revise the method again. In the first step, we will write down the given equation and we will keep it as equation 1. From that equation 1, we have to find out dy by dx, and we will make it as equation 2. If equation 2 includes any arbitrary constant like a or c, that arbitrary constant should be eliminated in the next step. It means we have to find out the value of that arbitrary constant from equation 1, and that value we have to put up in equation 2 for further simplification. So after that we will simplify it, and then we will replace dy by dx by minus dx by dy. Then we will do separating variables. After separating variables, we will integrate both the sides, and then we will find out its integration by using integration formula. So this is all about orthogonal trajectories. I hope you will like this video. Thank you.